In Algebra 2, section 8.3, says Algebra. This is Algebra, my apologies, 2.8.3, graphing reciprocal functions. Reciprocal functions basically look like these, where there's an x that is undefined and the y is undefined. So it's a over 1 over, what's supposed to be 1 over x, and x cannot equal 0. So a reciprocal function is a function that has a fraction with x in the denominator. Now, the graph, just like in a quadratic equation, x squared plus b squared, ax squared plus bx plus c, that's your quadratic equation. That graph is a parabola. This graph is called a hyperbola. Okay? And the asymptotes are these lines where the the graphs will go near but will not touch. Right? So it'll go near. So in a parent function, this one right here, the original reciprocal function, x will never cannot be 0, because if you do 1 over 0 in a calculator, it's going to give you error. But also, y will never be 0, because 1 over something, this can never be 0. So y will never be 0 and x will never be 0. And the place where it'll never be are called asymptotes. And that's areas where the graph is undefined. So you'll have an equation here where a over x is your original function. According to what a, h, and k are, is how I take the parent function and I shift it. So for example, the vertical asymptotes is x, which is where x is undefined. In this one is where y is undefined. Okay? And if a is bigger than 0, then it's reflected off this line. If a is bigger than 0, if a is less than 0, then it's reflected on the other side. So when we're graphing this, you just identify the a, the h, and the k, and then move the reciprocal function accordingly. So go ahead and pause and write this down, and we'll do some examples. So for the first one, it's asking us to identify the asymptotes, domain, and range. So the domain and range, the domain is where x is defined, and the range is where the x is defined. So once I find the asymptotes, I can easily find the domain and range. So the x asymptote, where it goes up and down, is where this is undefined, where x is. So I'll just do x cannot equal 0, so where x equals 0 is undefined. So x cannot equal 0 at 4. So this is my x asymptote. And then my y asymptote is that this whole thing will never be 0. So that means that this is never be 0. The only time this will equal 3 is if this is 0, so y is undefined at 3. One more time, the reason why it's undefined at 3 is because in order for this whole equation to equal 3, this has to equal 0. And this fraction will never equal 0, because 2 over something will always give value. So it'll either be bigger or smaller than 0, but never at 0. So then this will always be bigger or smaller than 3. So it cannot be x. So my asymptotes are x equals 4 and y equals 3. And then my domain is x can be anything but 4 and y can be anything but 3. So it's the same thing, but you're writing it in different ways. So number 2, we're going to be doing the same thing. We're going to first identify the asymptotes, and then we're going to use these information to shift the parent graph. So this is telling me that my A equals -1. My H equals, my H is this one, -1. Because this is x minus h. If it's a positive, then I need two negatives. So this has to be a -1, and my k equals +3. So my h tells me my x asymptote. I'm going to take this and I move it at -1. Because originally it's here at 0, 0. I'm going to move it at -1. Because at -1, x is undefined. Y is going to be 3. 1, 2, 3. This is my x asymptote. And because A is -1, because it's smaller than 1 right here, I'm going to have it on this side. So it looks like this. And that's how I graph. I'm not going to be too particular on exactly how you write the curve, as long as it's on the right position. So go ahead and pause and write this down and try page 549, number 5. 549, number 5, and I will see you in class.